Today's lesson is on divisibility, prime factorization, greatest common factor, and least common multiple. We're going to film this video in two segments. The entire segment, both segments will contain divisibility rules, prime and composite numbers, prime factorization, greatest common factor, and least common multiple. Our first segment will include divisibility rules, prime and composite numbers, and prime factorization. Now let's look at the divisibility rules. Divisible is when one number goes into another number evenly with no remainder, and these are the tests. A number is divisible by 2 if the number ends in 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of the digits is divisible by 3. The number is divisible by 4 if the last two digits are divisible by 4. The number is divisible by 5 if the number ends in 0 or 5. A number is divisible by 6 if it passes the test for 2 and 3. A number is divisible by 9 if the sum of the digits is divisible by 9. And a number is divisible by 10 if the number ends in 0. Now when I test the rules, I always lump the ones that are the same together, and it makes it go a little bit faster. So when we test, we're going to test for 2, 5, and 10 first, since they all look at the last digit. Then we're going to test for 3 and 9, since both of those look at the sum of the digits. Then we're going to test for 6, and then finally we'll test for 4. So we're going to take a couple of numbers, and we're going to do the divisibility test to see which numbers they are divisible by. The first number we're going to look at is 150. We're going to test this number for 2, 3, 4, 5, 6, 9, and 10. The first ones we're going to test by are 2, 5, and 10. So let's look at the last digit, which is 0. Since the number ends in 0, it passes the test for 2 because it has to end in 0, 2, 4, 6, or 8. The test for 5 is, does the number end in 0? Yes, it does. So it passes the test for 5. The test for 10 is, does the number end in 0? Yes, it does. So it passes the test for 10. But the test for 3 and 9 is to sum the digits. So we're going to say 1 plus 5 plus 0, and that equals 6. So the sum of the digits, 1 plus 5 plus 0, is 6. The test for 3 is, will 3 go into the sum of the digits, or will 3 go into 6? Yes, it will. So it passes the test for 6. The test for 9 is the same. Will the sum of the digits go into the, will 9 go into the sum of the digits? 9 will not go into the 6, so it fails the test. Now let's test for 6. The test for 6 is, does it pass the test for 2 and 3? Yes, it does, so it passes the test for 6. The test for 4 is, will 4 go into the last two digits of the number? Not the sum of the digits, but just the last two digits. So we're going to divide 4 into 50 and see if it goes in evenly. Since it does not, it fails the test for 4. So 150 is divisible by 2, 3, 5, 6, and 10, and of course all numbers are divisible by 1 and themselves. This makes 150 a composite number since it passes at least one of the divisibility tests. All right, let's take one more number, 2,103, and we're going to test this number for 2, 3, 4, 5, 6, 9, and 10. Now let's test for 2, 5, and 10 first. Does the number end in 0, 2, 4, 6, or 8? No, it does not. Number 5, does it end in 0 or 5? No, it does not. The test for 10, does it end in 0? No, it does not. Now we're going to test for 3 and 9, which means we have to sum the digits. 2 plus 1 plus 0 plus 3 equals 6. Can 3 go into 6? Yes. Can 9 go into 6? No. The test for 6 is, did it pass the test for 2 and 3? Well, it failed 2, but it passed 3, so it does not pass 6. The test for 4 is, can 4 go into the last two digits? 4 cannot go into 3, so it fails the test for 4. So 2,103 is divisible by 3, and of course 1 and itself. Both of these are therefore composite numbers since they pass at least one of the divisibility tests. Now let's try one that fails all tests. Let's try 41. We're going to test 41 for 2, 3, 4, 5, 6, 9, and 10. It does not end in 0, 2, 4, 6, or 8. It does not end in 0 or 5 or 0. So therefore it fails the test for 2, 5, and 10. The sum of the digits is 4 plus 1, which is 5. 3 cannot go into 5, and neither can 9, so it fails the test for 3 and 9. Since it failed 2 and 3, it also fails 6. 4 cannot go into 41 evenly, so it fails the test for 4. Since 41 failed all of the divisibility tests, it is considered a prime number, which means the only factors that make up 41 are 1 and itself. And that is the difference between prime and composite numbers. Now we're going to talk about the difference between prime and composite numbers. So let's see what those look like. Prime numbers are numbers that have only 1 in itself as factors. For example, 2, 3, 5, 11, and 41. 2 is the only even prime number. Composite numbers are numbers that have more than 1 in itself as factors. Example, 4, 8, 10, and 40. Prime numbers fail all of the divisibility tests, whereas composite numbers pass at least one of the divisibility tests. So as we do the factor trees, we're going to talk about the difference between prime and composite numbers. Let's take the prime factorization of 48. These are also called factor trees. We need to find two factors that when multiplied together equal 48. It doesn't matter which two because we're all going to end up with the same answer. I'm going to choose 6 times 8. Now if we look at 6, 6 is not prime because we can divide that by 2. So we're going to bust 6 down into 2 times 3. Now we're going to look at the 8. Since 8 is not prime because it also passes the 2 test, we're going to bust 8 down into its prime numbers, 2 times 4. And we're going to start over here. Since 2 is prime, we're going to go ahead and bring it down. Since 3 is prime, we're going to go ahead and bring it down. Since 2 is prime, we're going to bring it down. But notice 4 is not prime. It is composite because it is also divisible by 2. So we need to break it down into its prime factors, which would be 2 times 2. Now that we have 48 broken down into all of its prime factors, we're going to list them in order of least to greatest. So the prime factorization of 48 would be 2 times 2 times 2 times 2 times 3, or you can write it 2 to the 4th power times 3. Prime factorization is when you break a number down and you have all of its prime factors when multiplied together will equal back up to the original number. Let's try one more. Let's do the prime factorization of 28. Now for 28, I'm going to choose the two factors, 4 times 7. Notice that 7 is prime. It cannot be broken down any further, except 1 in itself. Those are the only two factors that equal 7. But 4 is composite because I can break it down. So I'm going to break the 4 down into 2 times 2. Since 7 is prime, I'm going to go ahead and bring it down. These are the 3 prime numbers that when multiplied together will equal 28. So the prime factorization of 28 is 2 times 2 times 7, or 2 to the 2nd power times 7. Now we're going to stop this segment and video the second part of the segment, which is greatest common factor and least common multiple.